Today we're going to learn about circle. Now what actually is a circle is that it's a geometrical figure, C-I-R-C-L-E, circle. It's a geometrical figure having a center and circumference. Now the center is at a point equal from any point on the circumference. So if here are infinitely large number of points on the circumference, and if we take any one point over here and join it to the center of the circle, it is the radius of the circle. These all lines I've drawn over here, these are the radius of the circle. Now if I draw two radius that passes from the center of the circle, it is called the diameter of a circle. And the diameter is equal to twice the radius of the circle. Here O is the center of the circle, say point A is over here, and here is point B. If we are given point OA, the length of OA is 5 centimeter, then we can say our overall length of AB, that is diameter, is twice the radius, which is equal to 10 centimeter. So the length that extends from point A to point B is 10 centimeter. As we know that there are infinitely large number of points on the circumference of the circle, here are infinitely large number of points. So if I take any one point, say here is point A over here on the circumference, and if I draw a straight line that passes from that point A, then this line I've drawn over here is called a tangent. It just touches one point on the circumference of the circle, and here is our radius O. And if I draw a line that touches the tangent and the radius, it is perpendicular. So here is CD. We can say angle OAD is 90 degree. That is, if we draw a point from the center of the circle to the point on the circumference from which the tangent line passes, then it makes 90 degree to the tangent. Any line that touches the 2 point, that joins the 2 point on the circumference, is called the chord, C-H-O-R-D. So if we take any 2 points, say I'll take one over here and one over here, and if I join this is my next chord. And we can draw a large number of chords by joining any 2 points on the circumference of any length. So if I want to know what is the maximum length or the maximum or longest chord I can draw in this circle or in any circle, it's the diameter. Here AB is the diameter of the circle that passes from the center O, and AB is the longest chord we can draw on a circle. Talking about the angles in a circle, we can make different types of angles in a circle. Say this is A or B. It's a one angle in a circle. As it stands on the center of the circle, we call it central angle. Central angle, as it is at the center of the circle, and if I take any point on the circumference and join it to point A and B, then this becomes my inscribed angle. So here angle ADB is my inscribed angle. Inscribed angle. And the property here is, if I know any one value among these two angles that stands on the same arc AB, if I know that the central angle is 60, then I can assume, or I can say that angle ADB that stands on the same arc AV is half the central angle AOB. The next angle I can make here is, I'll make one diameter and join it at the point on the circumference of a circle. So this angle is always equal to 90 degree. So what we can say is the triangle ABC here, triangle ABC, or I can say angle ABC is 90 degree. We can say it this way: angle in a semicircle is a right angle. Is a right angle. So here, this part is a semicircle, and the angle that stands over here is angle ABC, and it's equal to 90 degree. Now let us learn some basic properties of cyclic quadrilateral. Now what is a quadrilateral? Any geometrical figure having four angles, or you can say sides, is a quadrilateral. Here, I'll take 4 points on the circumference of a circle. 1, 2, A, B, C, D. And if I join this point, it becomes a cyclic quadrilateral A, B, C, D that stands inside of our circle ABCD. So the property here is, if I say this angle X and this opposite angle Y, they sum together to give 180 degree. So we can say X plus Y is 180 degree, and if I say this is A and this is B, they two are opposite angle and they sum up to give 180 degree. Yet another property of cyclic quadrilateral is that here ABCD is our cyclic quadrilateral, and the exterior angle here in this case is angle, sorry, I'll take a different color, angle BCE, because that lies outside of our quadrilateral ABCD, and this exterior angle over here is equal to its opposite interior angle. Here angle DAB is equal to angle BCE. If this is 90 degree, then this must be 90 degree. Now let me say something about arc and sector. Arc is if I check any two smaller section of circumference, it's the arc. Here AB is the arc of the overall circumference of the circle, and the smallest part that looks like a slice of a pizza is a sector. This is a quick summary of what we have learned today. Center of circle, radius, circumference, diameter, angles in a circle, here inscribed angle and central angles, cyclic quadrilateral and its properties, tangent, chord, sector and arc. We'll learn more in our next video. See you. Thank you for watching.